Hello everyone, I hope I am audible. Let me know in the live chat if I am audible and you can also see this screen. Let me know in the live chat everyone. Uh, there is some time to start the contest. Okay, thank you Varis. So let us start. So if you don't know, my name is Sagar and today in this live stream we are gonna try to solve GFG weekly coding contest questions, and I'm a little bit nervous today because that is my first live stream. That is actually GFG interview question. Like you remember this thing? It was formerly uh, it is somewhere here. Okay, that was interview series. GFG have to manage this thing. So we will start with solving the questions, and there are a total of three questions. So let me just start with this one. We will select Java, and let me know if I am audible, if my voice is clear. So I will just first read this question out. Binary good. We are given binary string of length n that is consisting of zeros and ones, and there are two inputs, that is string and a number. And a binary string is good if total number consecutive ones wherever present are equal. So that means we have to tell whether a string is good or not, and if total consecutive ones wherever present are equal. Okay, so that means we have to find the number of consecutive ones in our string. So first of all, we will traverse in our string and we will just get how many consecutive ones are present. And we have to tell all the consecutive ones should be have equal number. So let me just verify this thing. There are three consecutive ones, and yeah, that is not a good thing. Present at consecutive ones are present at three positions having length 3, 2, and 1. And okay, we have to perform operations, two type of operations. You can choose any index I and insert one here at that position. After this, length of string will increase by one. Okay, and choosing any index I such that index value equal to one, and we have to remove that value. So after this, length of string will decrease by one. So either we can add one or we can also decrease one. And our task is to make string good using minimum number of operations. Okay, I think we have to then return minimum number of operations. So like in this example, first of all, let me tell you what is a binary good string. So suppose this is our string 0111 00 111. So how many number of ones are there? So there are three numbers of consecutive ones, and that means whenever we have one anywhere in the string, we should have three consecutive ones. So there are three consecutive ones, and there are also three consecutive ones. And suppose we have two consecutive ones, and then zero, then one, then zero, then one. So suppose this is our example. So first of all, we got two consecutive ones in our string, and after that we have only one consecutive one, but that means they are not equal. So here are two ones and here is only one, and after that we have only one. So that means here are our two, what can we say, here are our two number of ones, and here is only one, and here is also only one. So that means we cannot say the string is good. So what we can do, we can just remove one from this. So we can just remove one. So number of one will be equal to one here, and then zero, then one, zero, one. So that means maximum number of consecutive ones are one, and now the string is good. So I hope you understood the problem, and let me know if you can clearly see this thing. Let me know in the chat section, everyone. So that is about this problem, and how can we remove this? So let us just talk about some base cases now. So what are the constraints? Constraints are 10 to the power 5. So that means we cannot use our n square approach, and we have to optimize it. So like in this example, 1 2 3 and 1 2 3. So we don't have to perform any operation, and the string is good. And here in this case, there are 1 2 3, and there are 1, 2, and then there is 1. So that means we have to do two number of operations. So that means first of all we have to get all the number of consecutive ones. So first of all 1, 1, 1. So we can get this three count, and there are some number of zeros then, and then we have again number of ones. So there are two number of ones, and again we have some number of zeros and then one. So that is our case. So first of all we need that number, right? So this three, this two, and this one. So first of all we will get this number, and I think we can also store it. So first of all, we will store this number 3, 2, and 1. And after that, we have to find what is the closest one. And we have to do minimum number of operations to make them equal, right? So how can we make them equal? So we know 3 can be reduced to 2 with one number of operations. So we did one operation and decrease it to 2. And 2 is exact same. And we can add 1 to this, and it will be also 2. So one operation here. So total number of 2 operations we did. And now all the consecutive ones are equal. Or what can we also do now? Instead, what we can do, we can make all of them 3. So if this is 3, we can add 1. So it will be also 3, one number of operation, and we can add two ones here. So two number of operations here. And this will be also 3. So there are total of 3 operations we are doing here. But that is not the minimum number of operations we are doing. So in order to minimize the number of operations, what we can do, we can just find some median value, and then we can change it to it. So I think now let me just think of some base cases. Suppose this is our 100 number of 1000 number of ones are consecutive here. So in this case, suppose there are 1000, then there is 2, and then there is 1. One number of consecutive one. So I hope you are understanding this problem right. And so when there is 1000 number of ones, what we can do? So we were just finding the average. So what is the average? 1003 divided by 3. So it is approx, I think it is approx 300 something, right? So it is approx 300. So that means we have to make all of them 300. But we don't have to do that, because even when the average of all these three numbers are 300, we can still see, we can just remove this, and we can just remove this. So using three number of operations, we have only 1000. So what we can do, we can just remove this, and we can remove this. So 3 will be remaining. No, three is our answer, and 1000 number of consecutive ones are remaining. So that is our case. So we have to also remember that case. So what can be our approach? So let me just think more of our base cases. So first of all, we need this number. We need one consecutive ones number, right? So first of all, we should first think before we start coding, right? And if you have any suggestion, you can also let me know in the live chat. So what can we do now? We have this number, and when we have some large number, so what we can do? Or when we have 3, 2, 1. So in this case, what we are doing? First of all, we are decreasing it to 2, and we are increasing it to become 2, and one operation here, one operation here. So how can we know that we have to make all of them equal to 2? Okay, we don't have to go with brute force, because that will not pass. Constraints are high, 10 to the power 5. So what can we do? I think we have to also check for this case, when we have 1000 and 1 and 2. So in this case, we have to just remove this one, and we have to remove this 2. So in this case, we have only 3 operations, and this will be our 3 will be our answer. And in this case, 1 plus 1, 2 will be our answer. So how can we verify? Either we have to remove this one, or we have to add someone. Okay. Okay, I think we have to return minimum. Yeah, its size is n, and input parameter, and return an integer denoting maximum length. But here we have to return Let me just read it carefully. Your task is to make given string good using minimum number of operations. Okay, and here we are given. We don't have to read input or print anything. Our task is to complete the function which takes two parameters, and we have to return an integer denoting the maximum length. But here in our example, we don't have to return the maximum length. Instead, we have to return the answer. That is how many number of ones we have to add or remove, how many number of operations we have to do. Or I think 1, 2. I think we have to return the length of how many number of ones should be there. So I think I was approaching the problem wrong, denoting maximum length. Okay, all right. All right, we have to, that is not the problem. We have to return the maximum number of ones we can have. So when we have 1 1 1 here and 1 1 here and only one here, so that means we will increase it to 2. So number of one will be 2 here, and our operations is 1, and we can reduce 1 from here, and our this is our second operation. So answer should be 2, but this is not the answer that we have to return. We have to return the length of our consecutive ones. So we have to minimize our number of operations, minimum number of operations. So here are two minimum number of operations, and we have to return the maximum length. So maximum length with that we have to return. Okay, so first of all, our main task is to minimize the number of operations, and then we can return the maximum length of our ones. So how can we do this? Let me just think of more of it. So when we have 2 and 3 here, 1, 2 and 3. So first of all, this I think we have to, how can we minimize the number of operations? We cannot find average because that will be not a good case when we have 1000. When we have somewhere like 1000 here, so we cannot just find the average. We have to return the minimum number of operations to make them all equal, or we can make them 0. So we can either remove them or make them all equal. So we have to consider either we have to take this one in our answer or not. Either we can make them equal. So how can we make them equal? Okay, I think there are only two cases. Either we can make them average, or either we can just remove this. So if we have here 500, so suppose in this case, so if we have 500, what we can do? This is 1500. So 1500 by 2 is 750. So what we can do? Either we can just remove this 2. Yeah, we have to remove this. So total number of operations will be 2, and this is our number of operations, and these are our number of ones. Okay, and after that we have to make them equal. So it is around 750. So plus 250 operations to make it 750, and after that plus 250 operations to make it 750. So it is around 250 from here, 250 from here, and when we have, this is 500 and 2. So these two, so 502 are the total number of operations that we are doing, but that is not the case. When we are doing on, when we are just removing this 500 also, the maximum answer will be 1000, and here the maximum answer was 750. So that means we have to make our maximum answer 1000. So we have to also remove this 500. So how can we solve this problem? Okay, I think I'm feeling dumb because that is an easy level question and I'm not getting the approach. So either we have to remove this, and if we have some priority queue, I don't know why I'm thinking of any approach using priority queue. When we have some numbers like 2, then in our heap we have 500 and also 1000. So I think we have to get the maximum one first. So in our next sheet, we have 1000 at the top, and after that we have 500, and we have 2 here. So when we have 1000, we will first get the answer will be 1000. So we will just remove this from our priority queue, and our next step will be to get this 500. So after this, we will have 500, and we have to check either we have to maintain this 500, or we have to make it equal to, we have to increase it to make equal to 1000, or some average value, or we can just remove this. So how can we check now? So if we are removing this, then we have to do 500 number of operations, because we have to remove 500 number of ones. So if we are removing, then we have to do 500 number of operations, and if we have to make it equal to this, then we have to take average. So what is the average? So average will be 750. So average will be equal to, we have to make this one equal to 750, and we have to make this one equal to 750. So it will be now 250 for this side and 250 for this side. So it will be 500 also. So that means we can just remove this and keep it as our maximum answer. Okay, that looks like a good approach. And let me just take some more examples, like our first example. 1, first of all, we will get 3, then 2, then 1. And we also have to take a variable that will tell how many number of operations that we are doing. We also have to minimize the number of operations. So first of all, we will get this 3. So 3 is here, and after that, we will have this 2. So first of all, this is our maximum value. We have to maximize the answer. So there are two things that we have to do. Let me just write it here. First of all, we have to maximize the answer. And I think first task should be to minimize the number of operations. So this is our second task. So maximize the answer will be our second task. First, we have to minimize the operation. Minimize the operations, okay? And so when we are removing 3 from this, after that we will have 2. So either we have to remove this 2 entirely, or we can just make them average. So what will be the average value of 2 and 3? It will be around 2. So we have to do one number of operations to make them equal to each other, right? So either we can add this and we can remove this. So if we are going with brute force approach, that will be not optimal. We can also go for DP, but let me just see how we can do this. Hello, Naikaj. I think my pronunciation is correct. Naikaj, hello. And so we are talking about here first question. First of all, that is the thing, we have to get the number of ones. And what we can do here, we can maintain a DP that will tell us our steps that we are doing. So that will be our so at this step, what we can do. So if this is our recursive function, but I think DP will also take time and square. So that is not optimal problem, optimal solution to go for. So if we have to make both of them equal, then either we have to do one number of operation and make it to 2, and we have to do one number of operation and make it 3. So after that, there are now two choices. So we have to take the average, and now there are two choices. Either we can make it 2, or we can make both of them 3, and the number of operation is 1. Okay. And after this, we have removed 2, and after that we have 1. So when we have 1 here, so we have 1, and we have two choices. Either we can make 1 to 2. So now there are, when we have to make 1 to 2, then we have two choices. Either we can just remove this 1 entirely, and there is one number of operation. And okay, so in this problem, I think the maximum answer can be 3, because if I am taking this problem correctly, the maximum answer should be 3. So we have 3, 2, and 1. So let me just write 1, 2, 3. So there are three consecutive ones, there are two consecutive ones, and there is only one. So we have to, first of all, we have to minimize the number of operations. We have to minimize the number of operations. And our second task is to, we have to return the integer denoting the maximum length. So we have to return an integer that will denote us maximum length. But why we are returning here 0? Okay, now I am getting confused. Maximum length of ones, or we can either return maximum length of this string, but consecutive ones are equal at both places. We can insert 1 at the end and remove 1 from index 2. So we can remove this one and we can insert 1 here. So total number of operations are 2 and the maximum length is also equal to 2. So let me just check for some another case. Let me just input some test cases here. Okay, here is to input our custom case. So our custom input will be 0, 1, 1, 1, 1. Three and so total number are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And what can be the answer? So first of all, we have four number of ones, and after that we have three number of ones and then one. So 3 and 1. So what we can do, we can just remove this. So number of operation is 1 and we can add 1 to this. So it will be equal to 4 and the total number of operations are 2. So the minimum number of operations are 2. So first of all, our task is to minimize. So we minimize the number of operations and the maximum answer is 4. So what we have to return, either 4 or 2. So let me just check now. I don't know, GFG is not providing complete proper statement. Okay, what is the answer? Your output 0, expected output 1. Okay, why it is showing expected output 1? 4, 3 and 1. Why am I returning 1? So either it should be either 4 or it should be either 2, but they are returning here 1. And I don't know why they are returning here 1. Let me just check it for one more time. So there are 4 consecutive ones, there are 3 consecutive ones, and there is only 1. So that means we can just remove this one here. We can just remove this one from here and we can just add 1 to here. So they will be equal, right? Or I think we have to return what is the difference in the total length and the new length. But they are not providing a proper what we have to return. Proper explanation they are returning. They are saying that we have to return an integer that is denoting the maximum length. But here we are returning 0 and here we are returning 2. So why 2? And I think we have less time for this question. Let me just quickly say, and if we cannot solve it, I will just move to next problem because we don't have to waste more time here. So first of all, we have 3 ones here, then 2, then 1. So what do we have to return? Now we are expecting we have to return the difference in our actual length and our new length. So we have to also maximize the length, right? So that means we have to add more number of ones with minimum number of operations. So we can just decrease 1 from here. So it will be 2 here and the number of operation is 1 and we have to add 1 here. So length will be same. So the original length of string will be same, but here we are saying that 2. Okay, why they are returning 2 here? Because the explanation is we can insert 1 at the end, and here we can remove 1 from index 1. So that means they are doing two operations. So they are doing here two operations. Okay, and they are returning operations, and they are doing zero number of operations and returning 0. So the output is 0. So in our input, in our example, they are saying that we have to return number of operations. But in this case, the number of operations are 2. But yeah, let me just cross verify if I'm not wrong. Let me just know if I'm wrong here. Okay, so let me just know if I'm wrong here. There are these 4 in our custom test input. So here is this 4, this 3, and this 1. 4, 3, and 1. Okay, so what do we do? First of all, we remove this. So number of operation is 1, and I think we have to add 1 to this. So this will be equal to 4, and this is our second number of operation, and the maximum length is 4. So we should return 2. 1 plus 1, 2, because we are doing 2 number of operations, and that is the minimum number of operations that we can do. Let me know if I am wrong. Anyone, if you are also trying to solve this problem. It should return 2, but I think there we are returning 1, and I don't know why. Okay, now that question is confusing me, so I'm just gonna leave it right here. I don't know why I'm so frustrated with this thing. This question was very irritating. So there we have another binary string question. Now that's cool. So there are n people standing in a row. Let me just see this question. There are n people standing in a row, and you are given a string s of length 1, where someone denoting 1 if ith person is infected with a virus. So if we have a length of n, and if we have some number here, there are n people in the row, and if we have some value equal to 1, so that means this person is infected. Okay, and if that is value is equal to 0, so that means it is not infected. 1 0, this is here 0, and given k, ith person can infect up to k people on his left side. So we have also a k integer that can be effect of our virus. So ith person can infect up to k person on his left side and up to k person on his right side. So if k equal to 1, so if k is equal to 1, so that means this infected person can infect this one and also can infect this one. Okay, now that looks like an easy question. And what we have to do, find the total number of people who are infected with the virus. So this is 3, and this is 3. So it should be 6, right? So when we have someone, we have to also infect the right person and also a left person. We have to infect k right persons and also k left persons, right? So there are 3 persons that will be infected with this one because k equal to 1. And after with this k, we also have to infect all these 3. So total of 6 person will be infected, right? Both third and sixth person can infect. Okay. So when k equal to 1, so we will just infect this 3, 4, 5. So answer will be 5. Okay. So that looks like a easy question. So what we will do, I think, let me just explain you my approach, what I am thinking of. So first of all, when we have this question, so we will just try with this in this example, because in this example we have overlapping infection problem, infection of people. So first of all, we have this line, and on that we will just create a character array. Why character array? Because it is the easiest way to change our values, right? So first of all, we have 0, 0, 1, 0, 1, and then 0, 0. So that is our example. And here what we will do. So we will just do, first of all, we will get any one, and we will just see what is the value of k. So first of all, what we will do, when we have one, we will just infect all the left k persons, because that is our initial value of 1. So we will just infect k left persons. So we will just infect this, and whenever we are infecting anyone, we will just say this will be equal to -1, or you can just add any other value. you can just add any different value, whether it should be not equal to 0 or 1. So we are just saying -1, so we will count it. So one person will be infected and this value is 1, so we will also count this. This is the infection in person with infection, okay? And after that we also have to infect the person on right. So we will also infect this one, and this will be also infected. So we will just say -1. And after that, after this one, so this person infected all the k person on right and left, and after that we will move ahead. So we will move to this is equal to -1, so we will not move here. And now we are here. So at this step what we will do, now we have to infect k left person and k right person. But when we are moving to left, we can see this is equal to -1, so we will not infect any person which have equal to value equal to -1. But we don't have to stop here. I think we have to stop it. We have to stop here, because if some person is here, then it should have infected all the values in between. So we whenever we have some -1, then we will stop moving, right? So when we are here, we will just stop moving and we will infect all the right persons. So we will just infect this one. So it will be also equal to -1. So after that, this value, so infection person, and after that this value which is infected person. So total value is equal to 5. So let me just quickly solve it. We'll create a character array. We will create an answer and we will traverse. I think we have to need indexes. I should be less than s dot length. That is the old compiler of GFG. And here what we have to do, first of all, we have to get anyone. If our kth value, no, ith value. So if error ith value is equal to 1, then what do we have to do? First of all, we will check how many left person do we have to infect. So like in this example, we have 0 0 1 0 1 0 0. So first of all, when we have 1, we will increment our count, answer plus plus, and now we have to check, we have to infect left k left persons, right? So now we will move to left side. So we have to use here a while loop, or we can use here a for loop. We will start from this I. I think we can use here a while loop. That will be better option. While I will create a j here, another variable that will be equal to, that will start from I minus 1. So first of all, if this is infected person, then we have to start moving to left from this side, okay? And j should be greater than 0, greater than equal to 0. And our second condition is we have to move to we have to infect only k persons, right? So we have to infect only k persons from left side. So how can we use this k? I can make a copy here. K equal to k, and k minus minus is greater than 0. So we can just move to left side using this k. So first of all, what we will do, arr I jth value will be equal to -1. That is a character array. Or we can, instead of using -1, we can just write here 2. Or if this is a character, so you can also write here x, y, z, any value, right? And after that, j minus minus. So let me just try run this thing. And every time we also have to increase our answer. And we also have to check for one condition, right? If our jth value is already equal to x, then we will break. So that is very simple for our left side, right? So suppose in this example we have k equal to 1. So we have to infect all the person on left and right with one value, one distance, okay? So this is our infected person. So we will just enter in this block and our answer will be equal to 1. And j will be equal to I minus 1. So j will start moving from this point, and k is equal to k. So while j is greater than 0 and k minus minus, so we are decreasing here, and we are using a post decrement operator. So while k minus 1, k is equal to 1. So k is equal to 1 currently, but it will be 0 after this line. So at this line k is equal to 1, but after this line it will be 0. So if you can't understand this thing, so you can just remove this and write here k minus minus. So that is equal. So that is a very similar thing. And so first initially k is 1 here, this small k, okay, and that is why we are making a copy here. That is a very important thing. If we are using our original k value, then we will just lose this, and k equal to 1, so we are here. So what we will do, we will check if this is equal to x. No, it is not, so we will just make it x. This will be x here, and our answer will be increased. So our answer is 2 now. So 2 answer. And after this, j will decrease and k will also decrease. So j will be here and k will be also 0. So k will be 0 and j will be here. And at this point, k is not greater than 0. So we will move out of this loop. And after that, we have to move to our right side now. So I will make another j. So j will be now equal to I plus 1. And now j should be less than s dot length. So j should be less than s dot length. And I will also again initialize this k. So and k should be also greater than 0. So now that means we have to just copy this thing instead of this line. So that is the only case when we are checking for left cases and not right cases. Okay. So we have to now change it to x. So all the right values will be definitely 0 or 1, right? So if it is not equal to, if it is 1, then we will break. Okay. So that can be the case. So if it is equal to 1, jth value, because if it is already an infected person, so suppose in this case when we are here, suppose the value of k is equal to 3, so we infected this person, and when we are here we don't have to infect this person because it is already infected, right? So and we don't have to also move ahead because this person will automatically infect other persons. So that means we just have to infect this person and we'll just break if we have any one already infected person. So if j is equal to 1, then we will just break out of this loop. And when we infected some person, that means it is equal to 0. So we will increment our answer and j will increase, but k will decrease. So I think now you got this thing, and let me just try run this thing. So we infected our left person and now we have to infect the right person. So value of k is equal to 1 here, and k is equal to k, and j is equal to I plus 1. So j will start from this point, and while j is less than length and k is greater than 0. So k is initially 1, but and we are checking if we have 1 here. No, this is not infected person, this is 0. So when we have 0, we will infect this person and increase our answer. So here the answer was 2, and so this person plus this person, 2 answer, plus now we also infected this one. So this will be also infected. So answer will be 3 here. And after that, so k will be equal to 0. So we will just break. And I think that is it. Let me just check. We have to return answer. So let me just check for test cases. Okay, we are also given a hint here. Okay, I don't want to see. So why is this giving a wrong answer? Equal to 0. I should be less than length. But okay, we are checking for 1. We have to check for character. That was the problem. Okay, now it is giving a correct answer. So let me just check it for another test case. So 0, 0, 1, 0, 1, 0, 0, and k is equal to 1. So it should return us 5. Let me know if you understood this problem. This is an easy question. If I'm not wrong, that should pass all the test cases. And what is the time complexity? 2 into 10 to the power 5. So it should be also, our time complexity is ofn, and space complexity is also ofn, because we don't have to manipulate with all the string values. So what is the wrong test case? Let me just check. So that is our case 0, 0. You don't have to enter any wrong submissions because that will just deduct your mark. Well, 0, 1, and at last triple 0, triple 0. So that is our example, and k is equal to 1, 1, 1, 0, 1. Yeah. So what we are doing here? So let me just dry run with our algorithm. The answer should be 7. Let me just see 0 0, and it should be equal to 1. So what we are doing here, first of all, we are at this point and we will infect this person. So we are infecting this. So currently the answer will be 2 for this one and this infected person. And we will not move to right side. So the expected answer is 6, but why? Let me just check what we are doing wrong. So the answer is 2, and when we are moving to right side, we don't have to infect this person. So when we are moving to right, so we are starting from I plus 1 and k is greater than 0, yeah. So when we have 1, we will just break. So we will not infect this person. So answer is initially 2. So we selected this and this. So we will not infect this person, okay? And yeah, we also have to check for this side. So it should be also not equal to 1. So that is the case. Or here are j equal to 1. So that is our another base case that we were missing. Let me just check for that input value. Hi star code. Glad you are also a content creator. I will just check your channel after this live stream. So now our answer is correct, and let me just submit it. We have only 50 minutes remaining, and we have 2 questions also. Have to solve 2 questions more. Okay, so now our solution is accepted, and let me just start with third one. We will select Java, and that was an easy question. I don't have to count it. So first of all, label the tree. So it is a tree question. I just love to solve tree problem. So we are given an unlabeled tree of n nodes number from 0 to n minus 1. Okay, and that is rooted from 0. We have to label every vertex of the tree. So we have to label all the vertices, and such that if the label of ith node is x, then there are m nodes of the subtree of this node. Then there must be exactly floor of m minus 1 by 2 nodes whose label must be smaller than x and the subtree of this node. Okay, I don't understand it. Let me just read it again. So we are given an unlabeled tree of n node numbered from 0 to n minus 1. So let me know if every one of you just understood the previous problem and either you solved it by yourself. Okay, so that is rooted from 0th node. We have to label every vertex. Vertices means that is their node. So we have to label them such that if the label of ith node is x, then there are m nodes in the subtree of this node. So if the label of ith node is x, so what does that mean? So if the label of ith node, so if we have first of all an array that will represent our tree. Okay, so we have here 5 nodes that will represent our array. So if this have a label of x, we have to first of all label our tree. Okay, and if the label of ith node is x, then there are m nodes in the subtree of this node. So then it should contain some m value of number of children. M nodes in the subtree of this node and in this node, then there must be exactly floor of m minus 1 by 2 nodes whose label must be smaller than x in the subtree of this node. Okay, I think I am understanding it a little bit. So if the label of this is some value, then okay, there are m nodes in the subtree of this node, then there must be exactly floor of m minus 1 nodes whose have m minus 1 by 2. So m means, so let me just write it here. First of all, what is m? So first of all, what is m? M is the number of children nodes of I of ith node. Okay, so m is the number of children of ith node. And what do we have to do with this m? So whenever we have some m, there are m nodes in the subtree of this node, then there must be exactly m minus 1 by 2 nodes which have whose label must be smaller than x. So x is the ith is the label of ith node is x. Okay. So x is the label of ith node. Let me just also write here label of ith node. So whenever we are checking for any node, I means any node in our array or in our tree. So x is the label of our ith node and m is the number of children of ith node that have x or that have a label equal to x. Okay, so that is how you can understand it. So x is the label and m is the number of children of x. Then there must be exactly m minus 1 by 2 nodes whose label must be smaller than x in the subtree of this node. Okay, so there should be exactly m minus 1 by 2. So m is the number of children and m minus 1 by 2 should be the number of nodes who have a smaller label than x. So that is the thing we have to check here. And we are given, so let me just write here, check if m minus 1 by 2 children nodes have small label. So I think now you can understand it. We have to check if there are this many number of nodes, this many number of children nodes of x are present that have smaller labels. So we have to check for all the labels in our children of x, and we have to check the number of children which have small label should be equal to this m minus 1 by 2. So I hope now you can understand this thing. And we are given parent array where parent I is the parent of ith node. Okay, that means it have no parent, and the parent of this first node equal to 0, parent of second node is 1, and parent of third is also 0, and parent of fourth is 1. So the tree is something like this. Okay, so that thing is clear. And we can also construct a tree. We can literally construct a tree from this, but we don't have to do that. From ith node from 1 to n, and we have to return an array where result I is the label of ith node. If there are multiple solution, return any. We have to return an answer result array where every element in that array is the label of ith node. Okay, that thing is I don't think I understood that. We will label the vertices as follow. Okay, so we ourselves have to label. That is not the actual label, right? We have to label we have to give some values to our vertices. That is just the index. So this is 0 index, this is 1 index. We are just given the tree and their relation between their nodes. So this is not the actual label. We have to label it, and we have to also satisfy all these conditions. That if let me just construct the tree. Okay, so first of all we have 3, and let me just first make the simple tree. 0, this is here 3, this is here 1, 2 and 4. So initially this is our tree, and these are not the labels, these are just indices. So this thing is given. Okay, and after that, why the output is 1, we have to return an array list. Let me just read it completely. We have to return an array is the label of ith node. If there are multiple solutions, we can return any. And all the labels must be distinct, and value of a label should be less than or equal to 10 to the power 5 and greater than or equal to 1. So we have to pass here unique labels, and label value should be also less than 10 to the power 5. Okay, that's not a problem. So you can just see this thing. We can also pass here number of label that can be also greater than our index in our tree. Okay, so first of all, let me just see this thing. So this is our tree, and now we have to label it, and we also have to satisfy these three conditions. So x is the label of some ith node. So if we are saying that x is the label of this node, so suppose it is here 1. So that means we are saying 1 is the label of this node. So I'm saying 1 is the label of this node. So I have to write here 1. and let me just create them as nodes. So, okay, I have to also remember the order. So this is our first value. This is our first value. This is our second value. This is our third. This is our fourth, and this is our fifth. So we have to make them like this order. So I will just make them nodes now. So this is our first. So these are all the empty nodes and they don't have a label initially. And what do we have to do? First of all, we have to pass them labels. So first of all, I am supposing that I am passing here one. So if the one is the label of this node, then we have to also satisfy multiple conditions that m is the number of children of that node. So how many number of children this have? One, two, three, four. So it have four number of children. So four are the total number of children of this node. Okay. And m is the number of children. Okay, and after that we have to check if there are this many number of children have small labels or not. So m minus 1 by 2, so that means 4 minus 1, 4 minus 1, that is 3 by 2, so 3 by 2, so it is here 3, so 3 by 2 means 1, so there should be at least one children. So that means our n minus 1 by 2 is equal to 1. So that means there should be at least one children. So one children should be present of this node that have label lesser than this. So the label of this node is equal to 1 and we cannot just pass the label as 0. So that is the thing you can also see here. Here you can see where we can pass the label that first of all label should be distinct and or equal to 10 to the power 5 and greater than equal to 1. So that means we have to at least pass the label as 1. So we cannot pass any label that is less than equal to less than 1. So no children node of this node can have a label less than 1. So that means our condition is not satisfying. So we will just remove this label. And first we are passing the label as 1. Now we will pass the label as 2. So now the label is 2 and we have to find at least one children which have a label lesser than 2. So we will just pass 1 here. No, we cannot pass 1 here because then there will be no children. I think we can pass. Okay. So let me just pass here 1. So that means now there is one children which have a label. Now there is one children node which have a smaller label. Okay. So now we are satisfying all three conditions. And after that, we will check for this one. So now we will check for this. Okay. That thing is not fixed, right? So we have to also see this thing. That thing is not initially fixed. We can also change this thing later. But how can we solve this? That looks like a hard level question. And we don't need to read input. Your task is to complete this and return an array that is consisting of labels of all nodes. If return label satisfy all conditions, then driver will print -1. Okay, so that task is of driver that either we have to print 1 or -1. We just have to return a array list of size n. So first of all, these are the three conditions, but how can we solve this? Uh, this can be the thing that this is our 2. That we have to start putting values from the minimum value from all the children nodes. So we don't have to start checking from the root node. We have to start adding labels from our children nodes because that is the case. That's how we can say we can pass the minimum label. So first of all we will start by this. So first of all we will pass the label as 1 here, and if we are passing the label 1, okay, let me also create an array that will be of 5 length. 0, 1, 2, 3, 4. So first of all, we are passing here 1 to our third value. Okay, so this was our third value. Here you can see it is here third, and here it is our third value. Okay, yeah, we are doing right. So it is our third value 0, 1, 2. So first of all, we are passing here 1. That means there should be at least how many number of children it have. First of all, we have to get the number of children. So first of all, we will get number of children. So it have 0 number of children. So this is our first step. So to solve our problem, we have to write here some steps. So our first step is to we can just do that with recursion, because then it will be much easier for us. So first get number of children. So first of all we will get number of children. So it is here 0, and then we have to also check. Then our task is to provide m minus 1 by 2 number of children should have smaller label. So now we have to find all the labels that are smaller than 1. So now we will traverse in all the children, and we will get number of labels that are smaller than this one. So is there a condition that we have to find exactly? Okay, exactly. So we have to find number of children that are exactly lesser than. So if our number of children is 0, then we have to find 0 minus 1 by 2. So 0 minus 1 is by 2 is minus 1 by 2. So it will be automatically 0. So there should be 0 number of children that have exactly exactly small label. So there should be 0 number of children that have a small label, right? So we can see there are 0 number of children from this node. So that condition is satisfied. So we can just put here 1. We can just move this. And now we have to talk about this node. So now we have to talk about this, and we have to pass here 2 because we just passed there 1. So this is our children node. So the number of children is 0. This is our leaf node. So number of children are 0, and there should be also m minus 1 by 2 number of children which are smaller than 1, which are smaller than 1. So that condition is also satisfied. So we can pass here 1, and now we can check for this value. So either we can pass here 3. So whenever we are passing here 3, first of all, what we have to check? We have to check number of children. So number of children are 2. So first of all, we have got number of children, and after that we have to check m minus 1 by 2 children are there. So m minus 1 by 2. So that means 2 minus 1 by 2, 1 by 2, that will be equal to 0. So there should be 0 number of children. Exactly 0 number of children should be present which have smaller label. But for 3, we can see here there is 1 children, that is there is our first children that have smaller than 3. So this is our first children, and this is our second children which have a smaller label. So there are total of 2 number of children for this node which have smaller value, but we need 0 number of children which have smaller value. So that condition is now not satisfied. So we cannot just place here 3. We have to place here some smaller value. So what smaller value can we pass here? We can just now change it to, we can pass here we cannot pass here any larger value. We cannot pass here 2 because whenever we are passing here 1, so 2 is here and 1 is here. So 1 is the smaller value, but we need 0 smaller value. So whenever we need 0 smaller values, so either we can say we have to check all the nodes that need 0 smaller values. So yeah, we can write here 0 smaller values. Okay, we can maximally pass 10 to the power 5 value. So that means we can start from 10 to the power 5. We can also start by providing 10 to the power 5. So first of all, how many number of nodes are there that need 0 smaller values? So first of all, we need to find this, and then we can also see. So first of all, let me just write for all the nodes which need how many number of smaller values. So for this node, it has 0 number of children, so it also needs 0 number of smaller values. And same for this, it also needs 0 number of smaller values. And same for this, this is also leaf node. So this also needs 0 number of smaller values. And when we are talking about this, it have 2 children. So it have m number of children, and we need m minus 1 by 2 children with smaller values. So m minus 1 by 2, so it is here 1 by 2, that means equal to 0. So it also needs 0 number of children to have smaller values. So it also needs 0 number of children to have smaller values. And for this, so whenever we are checking for this, so first of all, number of children are 4. 4 minus 1 by 2 will be equal to 4 minus 1 by 2. That means it is equal to 1 here. So it needs exactly 1 number of children to have a smaller value. So that means there are this thing is, we can write this thing. So first of all, this need zero smaller values. So we can just provide here 10,000, 10 to the power 5, because that is our maximum value. So let me just write here 1, 2, 3, 4, 5. So that is our maximum value. So there is no value that is smaller than, there are so many values that are smaller than this, but this have no children, right? So that is why we are providing it 10 to the power 5, because there is no children to this value. And after that we can just pass here, it is 9, 9, 9. Okay, let me just do more. So we are passing here 9999, because that is also a very larger value, and there is no children here which have smaller values. Okay, so we are passing all the larger values in our root nodes. And now the turn is for this node. So it need exactly zero number of values which are smaller. So but it can have larger values. So when we are passing here 9998. So when we are passing this, so I think there should be 49. Okay, let be it. So 10 to the power 5. Now that means there are 10 to the power 5 nodes, and 10 to the power 5 maximum nodes can be possible, right? Okay, 5,000. So that means now this node, for this node we need zero number of smaller values for children, but you can see there is a larger value here and there is also a larger value here. So that means there are zero number of nodes which have smaller values. But yeah, we cannot just pass here like this. We cannot just pass here 999 or something like this. First of all, we have to also check for this thing, that there should be exactly one value which is smaller than this. So if we are passing here, 9998, then we can pass here 9997. So this is also a node that don't have any smaller values as its children. And when we are talking about this, so we can also pass here 9996. But now what is the problem? Let me just write it clearly. 96. So now what is the problem? So the actual problem is that you can see there is no children in this side or this side which have a smaller value. So how can we iterate? So first of all, we know that we have to find this thing, how many number of children it have and how many number of smaller value it needs. Okay, so we are just remaining 30 minutes. Let me just erase this. So first of all, we need to find this thing, okay? And there is a node. So this is our second thing that we have to find. Number of children for all nodes, and we have to check how many number of smaller child required for any node. For all the nodes, we have to also find that thing. How many number of smaller child is required? So for this, how many number of smaller child required? 1, because it has 4 children, and 4 minus 1 by 2 will be equal to 3 by 2, and 3 by 2 will be equal to 1. So it needs 1 children to have a smaller value than this. Only 1 children, right? So how can we now select all the values that this need only 1 children to have smaller value? So we can just pass here some random value, I think. No, we cannot pass some random value, because we need one value to be smaller than this. So what can we do? We can just pass it to just immediate children. So when we have here, we need some one only smaller value. So first of all, we will just fill these with our maximum value, our all the leaf nodes. So 1, 2, 3, 4, 5. So this is our maximum value. They need 0 children. So first of all, we will just fill our leaf node. So I can just write it here. Fill leaf nodes. So that is the thing we have to do. And everyone just click on the link in the description to get on this contest page. So first of all, we will just fill all the leaf node values, and after that, this is, let me make it a bigger node. This is here 9, 9, 9, 9. Okay, so after that we need one value. So for this node, we have to select only one children which have a smaller value. So first of all, after filling this, we have to also check which is the node which needs smaller value. And now we can just pass here. We can just write here 9, 9, 9, 8. And now we can pass here 9997. And you may be thinking why am I starting from 10,000 value and not 1, because we have a range of 1 to 10 to the power 5, and I am starting from 10 to the power 5 and not 1, because 1 is a very smaller value and we cannot just pass smaller value to all the children. Or I think we can start from 1. Let me just think of some another approach. So I think I got one idea. So here it have one. Okay. So first of all, we have to get how many number of small children this node can have. So this node can have exactly one number of small children, and for this it can have zero, it can have zero, it can have zero. So total number of small children for this node. So one. So first of all, we will get this one plus all the values for this all the values for all the children of this node. So first of all 1 plus this 0 plus all these three zeros. So plus 0 plus 0 plus 0. So that means this node will start from this node value will be equal to all these values plus 1, because it need exactly one children, right? So 1 plus this all values. So 1 plus 1 will be equal to 2. 1 plus 1 will be equal to 2. So that means this node will have 2, and 1 can be either here or it can be here. So we can just pass it to any children value. So now let me just check. So the next value, so now we have to always start from 1. Now we are selecting from now we have to start selecting from 1, and we just selected this 2, and then we have 3, 4, 5, and all the other values. So now we have to move to this side. So what can be the value here? So the value can be 0 plus 0 plus 0. So this 0 plus of both the children value. So it can have 0. So it can be 0. So uh, zeroth value, that means this value. So zeroth value means this value, and when we have 1, so we selected this value. So consider it as an index. When we have 0 index, so we selected this, and when we had 1 index, so we selected this. So when we need zeroth index, so we selected this one. So our 1 can be here, and for this node, so our array is now reduced, so we also use this. So we will start from this, and now 0 will be considered here, and 1 will be considered here. So when we have this value 0, so we will select here 3, and when we have here 0, so we will select here 4, and we have also 0 here, so we will select 5. So that can be also a legit answer. Okay, I think we got the approach. So this is the answer. Let me just write here. We don't have to fill the leaf nodes. We have to check for all the nodes. What we have to do for all the nodes, we have to first get how many number of small children it can have. For all the nodes, we have to check some conditions that are check how many number of small child it can have. So how many number of small child it can have? So this value plus all the values from children. All values from children. Okay. So we just got 1, and that means we have to select the 1 index value. So we also have to maintain this thing. That is our initial value. So in our initial value is 0, and we also have to select this thing. So how can we maintain this? That if the index is 0, so if the value is 0, that means we don't need any children. So we have to select this. So how can we arrange this thing? So I think we can just maintain an array of 10 to the power 5 length. Okay, let me just maintain array. of 10 to the power 5 length, and the constraints will be working numbers. And if we have -1, then that means we cannot select this. So when we are crossing this, that means we cannot select this. So we will just put here -1, -1, -1. And whenever we have 0, so for 0, we will select this. Or we can just remove this thing, right? So we can create an array list. But the time complexity will be 10 to the power 5 for creating that array list. Okay, let it be. Let me just check here. So whenever we have some value, we will just remove it. And I think we can create an array list of 10 to the power 5 length, because the number of constraints are 5,000. That means it is 10 to the power 3 approx, 10 to the power 3 by 2. So we can create an array list of integer. New array list. And we have to add all the 10 to the power 5 values here. All the 10 to the power 5 up to 10 to the power 5. So let me just make it a clear. So after that, we have to also create this whole thing into our array. So how can we create it into array? So first of all, okay, I just got confused how we can create it. So this is our array, and on 0th index we have 2. So on 0th index we have 2. On our first index we have so first index is here. On our first index we have 1, and on our second index, second, third, fourth. So it is second, it is third, it is fourth. So 3, 5, 4. So that can be also our valid answer. 3, 2, 1, 4, 5. So that can be also a valid answer. Let me just cross verify this if this is a valid answer. Okay, this need one children smaller, so it have one smaller children, and this need 0 smaller children, so it don't have. They also don't have 0 small children. So that means this is our valid answer. And now we have to fill. Let me just check if we are only initializing our solution with only one time. So that means we are checking for multiple test cases, and we are always initializing our solution class. So that means we have to do it in this. So for 1, 2, I should be less than equal to 1, 2, 3, 4, 5, and we just have to add I. So that means we will just created an array of values 1, 2, 3, 4, 5 up to 10 to the power 5. So now let me just cross verify this approach that we just depicted using our different example. Okay, so I think we just need some custom example. So what can be our custom example? So suppose there is this node, and there is these two. Okay, so this is our example, right? So the total number of so first of all we have to find there are the steps. First to get number of children of all nodes, and then we have to check how many number of smaller children required for all the nodes. So we have to write that thing. So for we will just start from our root node, and we can just use here DFS. So first of all, this has zero number of children, and same for zero number of how many smaller children they require. So we are writing here how many smaller children do they require, and I think we have to maintain two things: number of children, and no, we can just pass that from our DP. So I will just do here a DFS from our root. Okay, we are not given a tree here. So we are not given a tree here. So how can we iterate? So first of all, we need We need a tree, or we can just iterate in our array. So how can we iterate in our array? So this is there a 0. We don't have to make it tree, right? We can just iterate from our array. This is 0, this is 1, this is 2 index, this is 3, this is 4 index, this is 5, this is 6 index. So what our array will look like, so this is our input array and this is our collection array. So we'll call it collection. So first of all, this array will look like, so on 0th index we have -1 because there is no parent to 0. And for 1, 0 is the parent. For 2, 0 is the parent. And for 3, 1 is the parent. For 1 is the parent. For 5, 2 is the parent. And for 6, 2 is the parent. So that is our input array for this tree. Okay. And we will have 0 number of. So how can we DFS? So we don't have number of children or any node. I think we have to create a map. Or instead of just creating a map, we can create a we don't have to create a tree. That will be our long process when we are creating a tree. So when we have a tree, the iteration will be much easier. So should I create the tree or not? So I think we can make the tree, but let me just think. If there is another approach, we can also use here a map. So that means for 0, this is a binary tree, right? And nodes numbered from 0 to n minus 1, you have to label all the vertices like that. Okay, this is not a binary tree. There is nowhere it is written that it is a binary tree. So we cannot consider it as a binary tree. So first of all, we will create a map that will contain our root node and all the children nodes. So for 0, what are the children? So children are 1 and 2. So we can create a collection of children. So for 0, 1 and 2 are children, and for 1, 3 and 4 are children. So we will just use this map to traverse in our array. And for 2, 5 and 4 are children. So this is here a list of children. So this is not also a binary tree. So remember that thing. So for 3, we have how many number of children, and how can we also make this tree? So whenever we have some value, we will just add it to this. And so let me just make this map of integer to array list. So first of all, we will traverse and we will just get some value. So int children. So children will be the index I, and parent for that children will be equal to value on that index. Okay. So the children will be equal to 0. So initially I is equal to 0. So children is 0 and the parent to that value is equal to -1. So we also have to add that value in our map. So if we can just say map dot put if absent, put if absent, we have to put parent and new array list. So the time is very less and we have to do it quickly. I think we wasted more time on our solution first problem and we can't even solve it. So after that, we have to just map dot get of this parent and add the children value. So using this, what we can do, first of all, we will be at 0. We will be at this. So children is 0 and the parent is 1. So parent is -1 and the children is 0. And after that, we will be at this index. So children is 1. So children is 1 and the parent is 0. So that is the thing what we are doing. So for parent, we are creating an array, and we are getting that array of parent, and we are adding a children here. So that means for parent 0, we will add 1. And when we have 2, so the children is 2 and the parent is 0. So that is something like this. And we will just create a map 3, 4. So we will just create the tree like this. Okay. So we will make this tree, and let me just remove this. And we have to also traverse using the map, and the base condition is when the parent is equal to -1. So that is the base condition that when we have to stop. Okay. So let me just erase it quickly. And how can we traverse now? So that is the thing we need. So first of all, we need also another array that will tell us how many number of okay, how many number of uh, we can easily get how many number of children do we have. And for array, we have to write how many number of smaller children they require. So first of all, let me just write here. So 0, 0, 0, 0. They require 0 number of smaller children. And when we are talking about 1, so 1 have 2 children. So 2, m minus 1 by 2. So it have m children. M means 2. So 2 minus 1 by 2. So 1 by 2, that means 0. So it also need 0 number of children to be small. And or it also needs 0 number of children to be small. And for this, it need 3 plus 3. So for this value, it have a total of 3 plus 3, 6 children. So for this root value, it has 6 children, and 6 minus 1 by 2, that means 5 by 2. So it need 5 by 2 means 2. So it need 2 children to be small. Okay. So first of all, what we will do, we will just get we will get the value of index 2. So 0 index, 1 index, 2 index. So we will get this value. So we will just get this value and place it here. And we will also remove this. So 2 index will be now this. Okay. And I think the removal will also take time because we have 10 to the power 5 values, and we will shift all these values. So we will place this 3 here, and after that we will move ahead here. So we will just get it 1 here because it needs 0 number of smaller children. So we will remove this 1, and after that for this value we need 2. uh, so we will just remove this 2, and for this we need 4. So we will just remove this 4 also, and 5 will be here, or we can say 5 can be here. Or okay, so we are starting from root, so 5 will be here. So first of all, how we are traversing? So when we are traversing, first we are providing value to our root, and then to our left, then to our right. So this is how we are traversing. So this is a pre-order traversal. That means root, left, right. Okay. So after providing 6, we will just remove this 5, and then we have 6, 7. So we will provide 6 here and 7 here. Then we will create this, then we will pass all the values in this array. Okay. So we need another answer array list. Okay. I hope now you are getting this thing. Oh, first of all, let me tell you how we can traverse in this. So first of all, we will create this array small required. So we'll just fill that array. And I think you let me know in the comments if you understood the approach that I am talking about here. So how we are gonna traverse in this, and we are gonna fill that. So after that, so this is our first of all, we have to get the number of children. Okay. So how many number of children? We can also create another array for this for simplicity. For children equal to new array of length n. Do let me know in the comments, guys, if you understand the problem. There are 8 viewers at least, and we have to first get the children. So we will DFS, and we will get P map, or we can just traverse in map. We will start from 0, and we will fill this children array. So let me just do here DFS. So that will return nothing. We have a map of integer to array list. And after that, we need our node value, or we can say index. and we have a children array. So first of all, what we will do, int total children equal to 0, and we will just get the array list of all the children values that are present in the map that are immediate children. Okay, so we only have immediate children in our map. So for 0, we have only 1 and 2 as the immediate children. Okay, so this is our for 0, we have immediate children as 1 and 2, and we will just also we will traverse in our immediate children, we will just do a recursive call. So for all the immediate children, IMC map dot get of this index. And if map don't have that value, so what we will return? So suppose for our root for our leaf node, so for our two value, so this two will be not a parent of any value, so we will return zero number of children. So if our map dot not map dot contins contains key of this index. So if map doesn't contain, then we will return, and by default the value in our array will be 0. Okay, and let me just uh, dry run and fill the array. So time is very less, and I don't think we can complete this question, but we will still do it after the time is over. So first of all, what we will do, we will just DFS. Okay, I think yeah, we can just do DFS, and after that we will add the children from that value. So first of all, we will do DFS of map, and new index is immediate children and this children array. And after that, total children count will be equal to plus equal to for number of immediate children. So immediate children are map dot get of this index dot size. So two immediate children and all the children of immediate children. So first of all, we will just add the value of children of immediate child. So I hope now you understood this thing. I hope you got this thing, that first of all we are getting how many immediate children do this node have. So first of all, for our zero value there are two immediate children. So first of all, this value will be equal to 2, and after that we are traversing in all the immediate children, and that are 1 and 2. So we are traversing in 1, and first of all we will traverse and fill the children array. So first of all we traverse in our 1, and we filled that there are two values, two children totally, and for our two values there are also two children, and for rest of the values there will be 0. Okay, and after that, first of all, when we are checking for our 0, we will also add children of 1 and children of 2. So how many children of 1 are here? 2, so it will be 4. And how many children of 2 are here? So here are 2, so total number of children for our root node will be 6. Okay, so six children for our 0, 2 children for 1, 2 children for 2, and all the values have 4, 5, 6, 7 have 0 children, and that is the thing. Okay, so first of all we got the number of children, and after that we need the smallest required, so we will just create traverse in our children's array. Small required will be equal to of this ith value will be equal to number of children minus 1 by 2. Okay, so m minus 1 by 2, that is the thing. Minus 1 by 2, and this will by default return us the base value, floor value. Okay, exact floor value. So we have this required children array now, and for this we need exactly how many number of two children, I think. Yeah, 6 minus 1, 5 by 2 is two children we need, and then we need 0 0 number of children. Okay, so first of all we will just iterate, I should be less than n, and then we will return how many number of smaller children to be required, and that will be the index. Okay. So our answer array. So we'll create an answer array list, and I think we can do this question if the time is not less. So that is our answer array list. And first of all, what we will answer dot add. What do we have to add? We have to add a value. So first of all, we'll get the value from our this collection array. First of all, we'll get the value from our collection array, that is here 1, 2, 3, 4, 5, 6. And what index value do we need? The number of required children's value. So small required of this ith value. And we have to add collection dot get of this index. So that means smaller required for our ith value. So how many number of smaller required for our zeroth value? So we need two smaller values for our zeroth pointer, for our zeroth node. So we need two smaller. So that means we will return 2th value. That means here 3. So we will return 3 and we have to remove 3. So okay, time is over. And I think we can do this first problem with question 1. I don't think we can still do this. Okay, they just removed it. And I hope now you understand at least one problem, and just try this question by yourself, and I will also try to do this. And I think the approach is good. It should work. So let me know in the comments that if you like this video. I am also, yeah bro, I am also giving this question first time, this contest. It is also my first time. Yeah, I also bet that we cannot solve it. I hope you understand this at least one question, and the second question was a little bit tricky, but we also got the approach at least. So let me know in the chat section if this video was worth it. And yeah, thank you for watching. Thank you for coming, everyone.